little bit fast. Which pairs are complementary? So if they're complementary, right, you've got angle 1 or angle A plus angle B equals to 90. So which of these equal to 90? Well, this one equals to 100, so this is not it. That's not complementary. This, if you add, it gets 180. That's not it. 38 plus 52 does equal 90. Ta-da, we have our pair. So these two are complementary because they add up to 90. And the last one, obviously, adds up to 360, and it's not. Tomorrow, I'll give you some colors so that you can highlight. Okay, just another tool that you can use. What's the measure of angle FEG? So let's locate FEG. So this is F, that's E, and that's G. Right, so they want this value here. How much is this? But they tell you that DF, and I'll use red, these two angles, right? This angle and this angle are complementary. So we know that these two added, so 26 plus question mark equals 90, minus 26, minus 26, and our our unknown angle right now, 10 minus 6 is 4, 8 minus 2 is 6, is 64 degrees. So our missing angle is 64 degrees, okay? Complementary. If two angles are supplementary, which diagram illustrates the situation? Well, if they're supplementary, then they add up, right? Angle A plus angle B equals to 180. And the only one that shows that relationship, or instead of A and B, they use X and Y, but it's these two, because these two, this is 180, and they were split up into two angles. Angle X plus angle I supplementary, so it would be A. B, these two are supplementary, and X and C, these two lines are just parallel, so they're really nothing. Look at the diagram below. What is a pair of angles that are marked in the diagram? Well, the two angles are marked in the diagram. I refer to vertical angles. We know that these angles are congruent. They're equal to each other, right? So remember, when two lines intersect, one like this and the other like this, they create four angles, right? And opposite angles. These two are equal, and these two are equal. Two angles are complementary if they add up to 90 degrees. They do not have to they do not have to be next to each other. So we have a 40-degree angle here and a 50, so they add up to 90, so they're complementary. And this 55-degree angle and 35-degree angle add up to 90, so therefore they're also complementary. Two angles are supplementary if they add up to 180 degrees, right? So 40 plus 140. If you add these up, equals 180. Adjacent supplementary angles are also called linear pairs because they form a 180 degree angle. Okay, so in this case, angle 1 and 2, and these two, right? We're talking about these two, right? They're supplementary because angle 1 plus 2 equals 180. And the other pair of linear pairs, right? The two angles that add up to 180 is 1 and 3. So these two, 1 and 3. And notice that linear pairs because they share a common side. Right? So adjacent angles, well, these, so just definition here. These two are adjacent. They don't add up to anything. Okay, that just means that they share two things, the vertex here. And these two angles, angle 22 and angle 39, share side C right here. Right? Ooh, okay. A and B are vertical angles, right? So we call that vertical angles. A and B here, well, it's a straight line, so that's 180. So 180 split up into two angles, make them supplementary. They're also adjacent to each other, right? So which makes them a linear pair. Okay, so if you want to add on to A and B here are complementary. They add up to complementary. They add up to 90 degrees, and they're also adjacent. Okay, B and A, vertical angles. Right? This is vertical. This is again this angle A and B are complementary because they add up to 90. And these two are nothing. They're they're nothing. They're just adjacent. They don't add up to either 90 or 180. Okay, so now why are knowing the relationship useful? So they're useful because knowing the relationship between the two angles, I can set up my equations. Knowing that these two angles are supplementary, I know that 2x minus 51 plus 41 equals 180. 2x minus 10 equals 180, plus 10, plus 10, 2x equals 190, divide by 2, x equals 95. Okay, so if I went over here and I multiplied 2 times 95, and then subtract 51, 2 times 95 is 190, and 190 minus 51 would be 139. Right, so that makes this angle 139, and I know I'm correct because when I add 139 and 141, that gives me 180. These two angles are complementary, which means that if I add them up, I get 90 degrees. Combine like terms, so I have x plus 76 equals 90. I'm going to subtract 76 from both sides, and x equals 14. So I can come back here and say 14 plus 20, which makes this angle 34 degrees. And if I add 34 and 56, that gives me 90. Here, you don't have to set up an equation. We just solve it using relationship. Well, this is 125, which means angle y is 125 because they're vertical angles, right? What's the relationship between angle y and z? Angle y and z are supplementary, so 125. So if I take 180 and subtract 125, it makes angle z 55. And now that I know angle z, angle x is also 55 because they're vertical angles. I want the value of angle 1, so let's solve for these two first, and then I'll get to 1. So 6x minus 19, if they're vertical angles, they're equal to each other. So this is my initial equation. Minus 3x on both sides. And I get 3x minus 19 equals 32, plus 19 on both sides. And 3x equals 51. Divide by 3, divide by 3. X equals 17. So if x equals 17, let me plug it in here. I get 6 times 17 minus 19. 17 times 6, 42, 102, minus 19. 12 minus 9 is 3, and 9 minus 1 is 8. So that makes this angle here 83 degrees. Now, if this is 83, this angle right here is going to be 97 because they're supplementary. Okay, that's 83. Guess what? This is also 83. And if I know that that's a 97, makes this guy 97. What's the relationship between W and X? W, and where's W? W is right here. And X. No, sorry, W and Y. Notice that W and Y occupy the same position, right? Same location. They're both corresponding angles. So B. Given two parallel lines and a transversal, which pairs of angles are equal? Well, right now, I know that angle A and D. So let's look at each one by one. Letter A. Angle 1 and C. They're saying that A and C are exactly the same measurements. No, they're not. So I can cross out A. B. Angle A and angle E are the same. Well, angle A is here, angle E is here. They're equal to each other because they're corresponding. So that's check. And they're also saying that angle D and angle H are also the same. Well, angle D is here, angle H is here. They're corresponding, so they're equal to each other. So B is the correct answer. Okay. So I'll do C just to prove it that it's not. So C says that angle C, this guy here, and angle E are the same. No, they're not. They're supplementary. Okay, so they're not equal to each other. So that makes C not the right choice as well. Given two parallel lines, determine the value of X. Okay, so let me start filling this. If this is 125, this is 125, which makes this angle here the supplement, right, which is 55. not 55. Yeah, 55. And if that's 55, this is 55. So that helps me because now all I gotta do is go back to the bottom and fill in the same thing. This is 125 because it's corresponding. This is 55. And then therefore x is also 55 because it's vertical. Final answer, this one, right? So filling it in, filling all the spots in, kind of can be a tactic that you can use. Given two parallel lines that determine the value of x, well, right now you know that this and these are outside the parallel lines. They're diagonal from each other, so they're alternate exterior. So if this is 150, guess what? X is also 150. Not bad, right? So far? So far. What's the correct measure of the indicated measures? Okay, so let's fill this in. That's 120. Automatically, this guy's 120, right? Which makes y the supplement. So if z is 120, y is 60. And then let me put 60. And if y is 60, x is 60 because they're alternate interior. So let's look at the multiple choices. X is 60, y is 60, and z is 120. There we go. A is correct. B says x is 60, which is correct. Y is 120. That's incorrect, so that's not right. C, x is 120. No, it's not, so that's wrong. So that's incorrect. D, x is 120. That's also incorrect, so the rest is incorrect. So the correct answer is A. And these become, the more you do them, the easier you recognize the relationship. So these two are corresponding, so it makes them equal to each other. And then you just get to solve. Minus 2x, 2x plus 20 equals 60, minus 20, 2x equals 40, divide by 2, x equals 20. And there we go, right here. It's not asking us to go and substitute, so I won't. Again, know the relationship between these two. They are alternate interior, which means they're also equal to each other. We have x on both sides, subtract x. We get 45 equals 3x plus 15, minus 15 here, minus 15. 3x equals 30, divide by 3, x equals 10. Right there. It's a triangle now, right? So no more transversals. So what do we know about the angles, 3 angles in a triangle? Well, they add up to 180. So that's how I'm going to set up my equation. So 3x plus 4x plus 2x equals 180. 3, 7, 9, so that's 9x equals 180. Divide by 9, x equals 20. I want angle A, so I'm going to go back here and go 3 times 20. And 3 times 20 is 60 degrees. So angle A measures 60 degrees. This is the exterior angle theorem, right? Exterior angle theorem, which says that the outside angle, right, this exterior angle here, is equal to the sum of the interior angles, these two that are not adjacent to 120. So we can say that x plus 2x is equal to 120. That's what the exterior angle theorem. So now solve 3x equals 120. Divide by 3, x equals 40. So x is 40, which makes this guy here 2 times 40, which is 80. And realize that, hey, this 40 and 80 is 120, which is exactly the same value as that exterior angle. Repetition. So again, it's the exterior angle theorem. So we know that 120, this angle here, is equal to whom? To these two added up together. Minus 47, minus 47. X equals 74. Yeah, that's it. Same thing here. It's just a little bit more work, right? So this exterior angle is equal, so this exterior angle, 3x plus 45, is equal to the sum of these two interior angles. 2x minus 5 plus 8. Variables on both sides. How we do? Minus 2x minus 2x. We get x plus 45 equals negative 5 plus 80, which is 75. Minus 45 minus 45. X equals 30. And then now that we know that, we want to find this angle and this angle. Let's plug it in. So x is 30, so we get 3 times 30. That's 45, 90, 135. This is 2 times 30 minus 5, which is 60 minus 5, which makes this 55. Now, if I add 55 and 80, do I get 135? I do. So we know we did this correctly. Determining the value of x, again, it's a triangle. So we know that the sum of all these angles equal 180. So x plus 16 plus 78 plus x plus 24 equals 180. We got x and x, so we get 2x. Let's add these numbers. So 16, 78, and 24. 18 goes 1, so that's 10, 118. Plus 118 equals 180. Minus 118, minus 118. We get 2x equals 62. Divided by 2, divided by 2, x equals 31. Now, if you wanted to find the value of each of the angles, just plug it in, but they're not asking for that, so just want x. Here, this is given, so I forgot to tell you that, hey, these are parallel. How do I know it's parallel? Because there's this little sign here, so it's given to us that these two lines are parallel. Angle WST, which I'm going to put a little dot, angle WST, right here, this angle, and angle USV. Where's U and S and V? Where's V? And this one. USV, yeah, this one, right? And then WST, which is, oh, sorry, I made it wrong. WST is actually this one, right? So that's what this one is saying. And they're equal to each other because they're vertical angles. Okay. Next, change colors. Angle WST, which is this one again. And angle STX, STX, where's X? Oh, here it is. So this angle. These two angles are alternate interior. That's why they're equal to each other. And last but least, USV, which is this angle right here, and angle STX, where's X? X, which is right here. Those two angles, why are they equal to each other? Because they're corresponding. Okay. We already talked about that, so it's a repetition. So this one, for example, it's asking you, hey, what is this angle? What's this exterior angle? Well, let's call it X. Right? I don't know, I put a question mark. Let's call it X or A or B or C. And according to the theorem, if I add these two angles, the 50 and 60, it's going to be equal to the exterior angle X. So what's X? 110. Same thing here. This angle here, 8 plus 6x is equal to 30 plus 4x plus 2. Solve 8 plus 6x. Let's combine like terms. What is that? 2. 4x plus 32. Minus 4x minus 4x. Let's get rid of one of the variables. 8 plus 2x equals 32. Minus 8 minus 8. 2x equals 24. Divide by 2, divide by 2, x equals 12. So I'm going to go back here and plug it in. So 4 times 12 plus 2, 4 times 12 is 48, which makes this guy here 50 degrees. So, and on the outside, it's 8 plus 6 times 12. 6 times 12 is 72, plus 8 is 78. 4 times 12 is 48, plus 2 is 50. Oh, and then 6 times 12 is 72, and 72 plus 8 is not 78, it's 80. So this 30 plus 50 equals 80, and they are equal to each other, right? Those two angles. Right, not much left over. Okay, so now we're talking about this guy here. Let's plug in. Angle 1 is 60. Angle 3 is 50. Well, that's more than enough information to fill this in. So if angle 1 is 60, angle 4 is 60. Vertical angles. Angle 3 is 50. Angle 6 is 50. How do I find angle 2 here? Well, let's take a look at this. I know this is 180, yeah? They're telling me this guy's 60. They're telling me this guy's 50. So what is this missing one? Well, it's going to be 60 plus x plus 50. They have to equal to 180. So if I subtract 110 minus from 180, I get x equals 70. So that makes angle 270 and angle 570. Now let's look at the transversal, right? Here's my transversals. I change colors. Let me use this one. So if you look at this transversal and focus on that, or on that only, right? We can use, we know that angle 6 is 50, which makes angle 14 60. Why? Because they're corresponding. And that's all I needed to know, because now that this is 60, I know angle 8 is 60. And how do I find angle 7, 13? Well, angle 7 and 13 are, angle 7 and angle 14 are supplementary, which makes this guy 120, which makes 13 120. In this triangle, we have two angles, a 70 and a 60, so that adds up to 130. And if I take 130 from 180, I get 50, right? So in the triangle, I know two angles. They should add up to 180, which makes this guy 50. And if I know this is 50, guess what? 11 is 50. Hang on a second. I did something wrong. Yeah, I made something wrong. Oh. Sorry, apologies. Let's start again. Angle 1 is 60, which makes angle 4 60. That's okay. Angle 3 is 50. No, that was okay. That's actually, I'll do it again. So makes angle 2 70 because angle 60, angle 1 plus angle 2 plus angle 3, this is 180, right? So I already have 60 and 50, which makes this guy 60 plus 50 is 110. Take that from 180, get that 70. So angle 2 is 70, which makes angle 5 70. Angle 6 will be vertical from angle 3, which makes that 50. Okay, try this again. Now at the bottom here. If you look at the bottom, right, so let's focus on this guy right here, and this guy right here, and this guy right here. I can tell you that angles 6 and 14, right, angles 6 and 14, which is these two angles, angles 6 and 14 are corresponding, which makes angle 14 50 degrees. And if angle 14 is 50, angle 8 is 50. Which makes angle 70 120, because I took that from 180, right? Sorry, 130. And makes angle 13 130. Angle 9, I have a triangle here. Two angles added up is 50 and 70 gives me 120, which makes angle 9 60. And angle 11 is also 60. How do I find angle 10? Well, it's 180 minus 60, which gives me 120, and makes this guy 120. Sorry about that. Is it possible for a triangle to have sides with the length 19, 13, and 14? So remember what we have to do. We have to see if the combination of two sides is greater than the third side. So let's pick the first two sides. 19, if I add 19 plus 13, is it greater than 14? Let me pick another two sides. Let's pick 19 plus 14. Is it greater than 13? And the last possible pair would be 13 plus 14. Is that greater than the third side, 19? Well, let's see if it's true for all three of them. 19 and 13 is 32. Is that greater than 14? Yes. 19 and 14 is 33. Is that greater than 13? That's also yes. 13 plus 14 is 27. Is that greater than 19? Yes. So if all three of them are yes, yes, and yes, these three sides can be used to make a triangle. Okay. The measure of two sides of a triangle 11, 15 use an equality to express the range of the measure of the third side. So remember, here's something that measures 11. I want to make a triangle with another stick that measures 15. Let me put the other stick. This is 15, not to scale. So one possible triangle could look like this. Yeah. Now, what if I decide to do this? That's 11. And I want to do the 15 this way this time around. So another possible triangle that I can make, the third side will look like that. Now, notice that this third side can be of different measurements depending on how we put those two sticks, the 11 and 15, together. So there's a range here that we have to find. That third side can be from here all the way to here, right? So x, which represent the third side, can be between these two values. And how do we find those two values? Well, what do we say in class? Well, the shortcut is that we can find the sum of 11 and 15. So I'll write 11 plus 15. And then to find the minimum value, we're going to subtract 15 minus 11. So on the downside here, on the small value, it can be x has to be between 4 and 26. So that third side can be any number between 4 and 26, but not including 4 or 26. Okay, so 4.000111 to 25.9999. There you go. Same thing here. So the shortcut, and again, what are we going to do with the two values given to us? We're going to add them here. And on this side, we're going to subtract them. The big one minus the small one. So it's 1 less than x less than 25. So our third side can be anywhere between 1 and 25, not inclusive. Meaning don't include 1 and don't include 25. And the last one here, which of these can be the length sides of a triangle? So let's take a look at the first one, 7, 2, and 11. 7, 2, and 11. Can I make a triangle out of this? Well, 7 plus 2, is that greater than 11? And then 2 plus 7, sorry, not 2 plus 7. 7 plus 11, is that greater than 2? And then the other combination we can make is 11 plus 2, is it greater than 7? Now, if it's yes, yes, and yes, then it's a triangle. We can make a triangle. If it's no for any of them, we cannot make a triangle. So right off the bat, if you do the first one, you get 9 greater than 11. That's obviously not true. And I don't even have to do the other ones, because just by this failing the first inequality, it tells you that we can't make a triangle. So this, no. Second one, what does that say? It says 5, 12, and 12. So 5 plus 12, is it greater than 12? And then we're going to do 12 plus 12, which is greater than 5. And then we have another one, right, which is 5 plus 12 greater than 12. And they're the same, right? That's okay. So we get 17 is greater than 12, check. 17 is greater than 12, check. And then here we have 12 plus 12, right? 24 greater than 5, check. So it passed all three inequalities, right? Any two sides of the triangle is greater than a third. So does that make a triangle? Yes. Three, 5, and 10. So let's do 3 plus 5 is supposed to be greater than 10. 5 plus 10 is supposed to be 5 plus 10 is supposed to be greater than 3. And the last combination, 10 plus 3 is supposed to be greater than 5. 3 plus 5 is 8. Is it greater than 10? No. So it already fails this inequality. So we already know it's a triangle. But let me do the other ones anyway. 15 is greater than 3, so that's a yes. 13 is greater than 5, that's a yes. But because this guy failed, we can't make a triangle. Last one, 11, 10, and 8. Well, 11 plus 10, is that greater than 8? Yes, it is, because we got 21 greater than 8. Let's pick another pair. 11 plus 8, is that greater than 10? Yes, it is, because 19 greater than 10. And what's the other possible pair that we can make? 10 plus 8. Is 10 plus 8 greater than 11? We get 18 greater than 11. That's also true. So it's yes, yes, and yes. So this guy here, I can make a triangle as well. That's it.